So now we're going to introduce what's called the remainder theorem. The remainder theorem states that if I was to do synthetic division and had done my work and gotten x equals to 2, all that stuff that we have been doing, and then had actually written this out, this x to the 5th, and then gave some space, x to the 3rd, gave some space and put my 4, and made sure I had a 0x to the 4, and then a 0x squared, and then another 0x, and then a 4. If I did all that work, down here I'm going to get a remainder. And it might be 0, it might be a number, it doesn't matter. But what we're going to learn is that I don't have to do all this. The synthetic division is great, and it might be the way to go, but there's another way. The remainder is actually equal to f of the number in the box. If I just kind of bring that number over here that was in the box and just do f of 2, that will be exactly my remainder. Now, why this is convenient is because often we'll be asked, hey, is this thing is x minus 2 a factor? And the easiest way to do it is you just take 2 and plug it in to the function. And if the problem says, hey, what is the remainder, like this one does, well, then I just have to plug in 2 to the function and not have to do all of the division work to get the result. So this is a perfect opportunity for us to just plug in 2 into my function and find the remainder. So the remainder that I'm looking for is going to be 2 to the 5th plus 5 times 2 to the 3rd and plus 4. If I just throw that into my calculator, I should get 76. And if I actually did all the work of synthetic division with my 1, 0, 1, 0, 0, 4, and actually worked it all the way through here, I would get 76 as the result of my division. So we're going to do it again here. Notice that we've got 3x to the 5th plus 4, and we can do synthetic division, or if we're just looking for the remainder, when we're dividing by x minus 2, the result of the remainder will come from just knowing what f of positive 2 is. And why it's positive 2 is I would take the x minus 2, set it equal to 0, solve for x, and get x equals positive 2. Add 2 to both sides, of course. And then the remainder, if I had done all of synthetic division, my 3x to the 5th and the 4, I've got a lot of 0 placeholders that I would not want to miss. But if I did all that work, the remainder is just f of 2. That's what the remainder theorem says. So let's find f of 2. So this is my r. That's what I'm looking for. And so I just put 3 times 2 to the 5th power plus 4, which would be 32 times 3 plus 4. Final result of... Somebody save me with a calculator. 100. See, I knew one of the answers. So that gives me a result from my calculator of 100. This is the remainder that I would get had I actually written a 3 and then a bunch of zeros. So degree 4, degree 3, degree 2, degree 1, and then the 4. All that work with synthetic division would produce a result of 100 as my remainder. But saving the work here, just plug it in, f of 2.